Hello, dear chickens. Because I want to make sure that I don't get rusty on my craft, I thought I'd teach you a lesson today. And today we're going to be learning some math skills. So pay attention, okay? You ready? Because this is Mr. G's distance learning. Okay? Hey, wait. What happened to my students? Oh, they ran away. They were too chicken to learn math. Next time I'll make sure to get some termites because I know they like math because they like logs. Hello everybody. So now that you know what to do with one log, what do you do with a whole bunch of logs? Well, let's practice. Let's go through a lesson here on the logs. Today's lesson is going to be called Properties of Logs. But in order for us to understand the properties of logs, I need to go back and refresh your memory on the properties of exponents because they draw a parallel. So let's go back to the properties of exponents. As you will remember, the product rule here says that whenever you multiply common bases, what do you do with the exponents? You add them. That was the product rule. The quotient rule then says, what happens when you divide? Common bases, what do you do with the exponents? You subtract. And lastly, what do you do with the power rule whenever you raise something to a higher power? Well, you multiply the two exponents, so a times b, and you carry your base with you. Those were the exponential rules that we learned in the previous unit. This unit, we're going to make sure you understand the properties or the laws of logs, and they are the same. You see, what do you do when you are multiplying? Just like over here, you're going to add the logs. What do you do when you divide? Just like over here, you're going to subtract. And what do you do when you have a power? Well, you're going to put it in the front and you're going to multiply. They are called the same rules. This is called the product rule. This is called the quotient rule. And this is called the power rule. Same as exponents. Okay, so now let's go ahead and remind you what to do. So in the previous lesson, we learned that whenever you have one log, you rotate. Let's do that again. You rotate. One more time. You rotate. One log. However, when you have more than one log, 2, 3, 4, 1,000, you condense. Let's do it again. You condense. Let's do it again. You condense. Cool. And then next week, the lesson is going to be, what do you do when you have two equal logs? Well, now you are going to cancel. Yes, what are you going to do? You're going to cancel. One more time. What will you do? You will cancel. That's right. Alrighty, so now that you know the laws, let's go over a few examples real quick like for you. So here I have 3 examples of what to do with logs, and I'm going to go back to these 3 logarithmic rules, okay? So off we go, and now let's do some examples. Real quick like here. This one here is multiplication. And whenever it's multiplication, you are going to make sure it's addition. So this will be the log base b of 20. Multiplication turns into an addition, so plus log base b of a, and you are finished. So now let's try this one. This is division. So this is going to turn into log of 100 minus the log of c. But wait, we already been through this. 100 turns into 10 squared and is an invisible base of 10. So what happens when you have common bases? They cancel out and you end up with 2 minus the log of c. Let's try the next one, except I'm going to try a little bit tricky here. I'm going to give you a square root. Now keep in mind this is multiplication, and also that this is a power. And where do powers go? In front. Powers always go in front. So this is going to be 3 log base b of a. The times is going to turn into a plus. And now here we go. What do we do with the square root? Well, you remember power 1 root 2. So 1/2 power 1 root 2 log base b of c. Log base b of c. Oops, that b looks a little kind of big. It has to be small, just like that. And we're done. Remember, this is a power, it goes in front, and because this is a square root, power 1 root 2. So power over the root. Last one here. Oh my God, I've got 3 logs. Okay, so I'm going to make sure I end up with 3 logs. One for 36, one for D, and one for C. So this is going to turn into log base 6 of 36 plus, you'll notice it's plus because it's in the numerator. Anything in the numerator is plus. Anything in the denominator is minus. So plus 2 log base 6 of D. Powers always go in front. And then this one, because it's divided by, you're going to say minus 3, because it's a power, log base 6 of C. Log base 6 of C. Now you're probably going to say, I'm done. Whoopee! That wasn't too bad. One more thing. Be careful here, because this is a number. And with numbers, we got to keep going. Variables, you stop. This here is 6 squared. Oh my goodness, I forgot to tell you, this is not log base B, it's log base 6. So therefore, the 6 and the 6 squared cancels out, and this becomes a 2. Plus 2 log base 6 of, D. And then minus 3 log base 6 of C. And that is how you expand from one log to multiple logs. But wait, we're not done. What about the opposite of expanding? Well, what is the opposite of expanding? It is condensing. So let me go over a few examples of condensing and see if you can get them real quickly. Let me create some log base B of C plus, let me see, 3 log base B of D. What are we going to do with this? Well, first of all, you got to ask yourself the question, how many logs? Oh, there's 2 logs. And what do you do with 2 logs? That's right, you condense. So let's go and condense these into only one log. Log base B of C times D. Why times? Because whenever this is a plus, that turns into multiplication. Okay, let's try another one. Let's see if I can come up with one that has to do with, maybe a quotient. How about log base 6 of 72 minus log base 6 of 2? Okay, there's your minus. This is going to use the quotient rule. So this is log base 6 of 72 divided by 2. This then turns into the log base 6 of 36, and we say, woohoo, we're done. But wait, this is log base 6 of 6 squared, which means cancel your bases, and the answer is 2. Cool, let's try another example. We're almost done here. Oh, let's try one with parentheses. Okay, let's say 3 log of A minus the log of B. One with parentheses. Well, first I notice there's a minus. That means there's got to be a division. But this is a power because it goes in front. But what you got to remember is that this power, oopsie, wrong place, is going to have to go here and is going to have to go here. This is not your conventional distributive property, 3 log n minus 3. So it could be done that way, then you have to raise them to a power. But if you want to do it in one step, this is the log of, I see a minus, so there's got to be a division. And this is a cubed over b cubed, and we are finished. Remember, this is a power, so it belongs to both of them. Finally, the last one here, I'm going to try and give you more than 2 logs, because what do you do with a bunch of logs? So let's try log of x minus, 3, the log of y, plus, let's throw 1/2 in there, the log of z. Oh my goodness gracious, 3 logs. And what do we do when we have more than 2 logs? Yup, you got it, you condense. So let me go over here and condense this into only 1 log. I see a minus, so immediately I'm going to draw my conclusion that there has to be some division along the way. Now remember, anything that is a positive goes on top. Just the way if you're positive, you're going to go up there somewhere. And if you're negative, you're going to go down there somewhere. So be good. All right, so let's continue here with math. This is a positive log. That means that x goes in the top. This is a negative log, but this is a power. Powers go up there. Because it's negative, it becomes down here. And finally, this is a power which goes right there. But remember, this is a fraction, power over the root. which means the square root of z, and we are finished. I hope you learned the properties of logs today. So stay safe at home, and remember, if I can teach from anywhere, you can learn from anywhere. Have a blessed day. Bye. Good day, everybody. Today's lesson is on properties of exponents, and so before I begin my examples from your assignment, let me remind you of the rules yet again. And so in order for you to understand the rules, we got to start with the rules of exponents, because I'm going to draw a parallel between both the exponent rules and the logarithmic rules. So here were the exponent rules. Number one is that whenever you multiply common bases, x and a's, what do you do? X and x. What do you do with the exponents? You add them. So a plus b. Now I have common bases, but I'm dividing. So what do you do when you divide? You subtract. So the common bases of x, so a and b get subtracted. And finally, the last one here is what do you do when you raise to a power? An exponent, you simply multiply the two exponents, the one from the exponential and the one that's outside. So it becomes x to the a times b. This is known as the product rule because you're multiplying. This is known as the quotient rule because you are dividing. And this is known as the power rule because you are multiplying, raising to a higher power, okay? And therefore you multiply. Okay, so those were the rules of exponents. Let me now share with you the rules of logs, or the laws of logs, and you're going to see the parallel. What happens when you multiply? You're going to be adding the logs. What happens when you divide? You're going to be subtracting the logs. And what happens when you have a power? Well, the power goes to the front and it becomes multiplication. Going backwards, when we condense, whenever there's a plus, it'll turn into multiplication. Whenever there's a minus, it'll turn into division. And whenever there's a little power in the front, a number in the front that's being multiplied, like this guy here, it's going to turn into a power. Okay? Hope that makes some sense. So now I'm going to go over the reminders. And those are that what do you do with one log, what do you do with a lot of logs, and what do you do with two equal logs? And then also, what does it mean to expand? Well, one log, as we learned in the previous lesson, you're going to rotate and then simplify. More than one log, you're going to condense it and then simplify if you need to. And whenever you have two equal logs, you're going to cancel and then you're going to solve or simplify the logs, okay? Now we're going to ask you to condense. Condense means to make it smaller. We're also going to ask you to expand. Expand means to make it bigger into many logs. And that's what this means. Okay? So now we are going to begin your assignment. What is it, or where are these problems coming from? They're coming from properties of logs, letter B. Letter B. So as you follow along, here's the way you do letter B, and then you're going to be asked to go back and do letter A. If you've already done letter B, no problem. Simply go through all these answers, all these examples, look at the answers and see if you did them correctly. And if you didn't do them correctly, just simply correct them, okay? So they're all coming from here. I'm going to do the first 9 real quick like, and it says write as a sum or as different. In other words, they're basically asking you to expand. But if you have numbers, no exponents, it says. Okay, so here we go. It'll be real quick like because these are very easy. So what you're going to notice here in question number 1 is that this is a log of 34 times t. Since this is multiplication, it's going to turn into addition. And so therefore the answer is log of 34 plus, because of the multiplication, the log of t. And you're finished. The next one here, number 2, it says log of 78 divided by n. Well, now this is division, and with division with logs, you subtract. So therefore, it's the log of 78 minus the log of n, and you're finished. Like I said, they would be really easy. Number 3, you're going to notice that there's a power of 5 up here. So what do you do with the power? It turns into multiplication. So you will just get 5 log of n. Number 4, now we have the log of 100 times t to the 4th. So now I have to go ahead and simplify this. So I'm going to expand it by seeing that this is multiplication, so it's going to turn into addition. This will give me log of 100 plus a log of t to the 4th. However, 2 things are happening here. 1, this is a power, it's got to go in the front. And 2, this is a number. It has to be simplified because I have a base of 10. So that's exactly what I did in my next step here. And that is to change the log base 10, change 100 to 10 squared. The bases cancel. And of course, that's going to give me 2. Over here, this is a power, and power is always going the front. And therefore, you end up with an answer that looks like this. Okay, number 5. Once again, in number 5, you're going to notice that this is a power because I have 2 powers, 3 and 8, and I have multiplication. And multiplication turns into addition. So therefore, this is 3 log n plus 8 log of m. Powers always go in front. Done. Number 6, again, I have division, so it's going to turn into subtraction. So therefore, I'm going to expand this by saying log base 8 of x minus the log base 8 of 64. Now, normally we would be finished. However, 8 and 64 relate to each other somehow. So I'm going to fix that, and I'm going to change 64 by saying 8 squared. Yet the bases cancel again, and you're going to end up with log base 8 of x minus 2. Number 7, it says I have 88 to the 6th power. Since that is a power, you're just going to put it in the front, and you're finished. Why don't I keep going this time, being that this is a number? Because there's no relationship between 88 and my base of 10. That is invisible. Okay, and then this last one. Well, you're going to remember that anytime we have square roots or any roots, there's always power over the root. The power is 1, the root is 2. The power is 1, the root is 2 for both a and b. There's also a division here, which means that there has to be a subtraction. So anything that's positive goes in the top, anything that's negative goes in the bottom or turns into subtraction, right? There we go. So the answer is 1/2 log a plus, because it's in the numerator, 1/2 log b, and minus, because c is in the denominator, log of c. And we are finished with the first 8. Okay. Now we go over to the right-hand side of your packet. That would be this one, but beginning at 9 and 10, you're going to be seeing that it says write as a single logarithm. In other words, condense them into one log. Alrighty, so now here we go. This is number 9. So I'm going to notice that I have 2 logs, so I'm going to condense them. I also notice that there's a plus, which means if it's a plus, it's got to turn into multiplication. So I'm going to multiply 20 times 50. When you do that, you get log of 1,000. But there's a base of 10. So I'm going to change 1,000 into 10 cubed. So log base 10 of 10 cubed, which is my 1,000. And because my bases are common, I cancel, and the answer is 3. Number 10. Log of 5,000 minus the log of 5. Hey, that's a minus. That means that there has to be division. And yet again, I'm going to condense. So 5,000 divided by 5 because of the subtraction sign, which of course is the log of 1,000. And what is 1,000? Hey, it's 10 cubed. And so whenever you have common bases, 10 and 10, they cancel out, and the answer is just 3. Okay. Going over to number 11. In number 11, you're going to see that there's a plus here, and also there's a multiplication here, which is going to turn into a power. So in one quick step, voila, there's the answer. Log of m times the log of times n to the 4th power, right? Okay, let's try it again, but this time I'm going to put a subtraction sign in front of you there. So therefore, yet again, this is a power. Power goes up here, but this is a subtraction, so there's got to be a division somewhere, right? So log of b to the 7th all over a. Wonderful. 12. Number 13 is one that is going to give you parentheses. So because of the parentheses, you will remember that you have to distribute this to both of these logs. But you got to remember that it's not regular distributive property because this is logs. So these are actually powers. And the other thing to note is that there's a minus here, which means that there's got to be a division somewhere, right? So in one step, it is log of t to the 8th divided by r to the 8th. Number 14. This is, again, a subtraction, which means there's going to be a division. This is a power. This is a power. So when you write this in one step, it's log of y to the 6th divided by x to the 9th. Pretty simple. Oh my goodness gracious. Number 15 now gives me 3 logs. But wait, Mr. G, you didn't do 3 logs. I said 2 or more logs, right? So what do you do with 2 or more logs? You still condense them. Okay, so I see minuses. Remember that anything that is a minus goes in the denominator. Anything that is a plus goes in the numerator. And also that this is a 4th power, a 5th power, and a 6th power. So in one step, there you are. The plus goes in the numerator and my 2 minuses go in the denominator as powers. Number 16. This is log base 10 of 2 plus log base 10 of 5. Now, I didn't have to say log base 10 because it means exactly the same thing. But it is a plus, which means I'm going to have to multiply, right? So this is log base 10 of 2 times 5. Well, 2 times 5 is 10. So log base 10 of 10 to the 1 power, the bases cancel and the answer is just 1. Okay. Number 17. I have a subtraction there, which means I'm going to divide yet again. So here, this guy here is positive, goes in the numerator. This guy is negative, goes in the denominator. So when I do that, I end up with log base 3 of 27 over 3. However, you will remember that 27 divided by 3 is 9. And 9 turns into 3 squared. So when you cancel out the bases, the answer is 2. Okay. Number 18. I have a power here, n to the 4th. I have a power here, m cubed. And of course, a plus, which is going to turn into multiplication. So log base b of n to the 4th times n cubed. M cubed, right? Number 19. Okay, let's see what this guy brings. Again, I have a power of 2, so it's going to go up here as n squared. I have a power of 4, and it's going to go here as m to the 4th. However, that's a minus. So which means it's division. And yes, believe it or not, we're done with that one. Couple more here. Number 20. Oh my God, 1, 2, 3, 4 logs. What do I do with 4 logs, mister? Oh, 2 or more, you condense. So let's condense. Alrighty, so I see a plus here, a plus here, a plus here. All those are going to go in the numerator, but I see a minus here. That's got to go in the denominator. So believe it or not, in one shot, there's the answer. Plus goes in the top, n to the 4th goes in the top, m cubed goes in the top. Because of the minus, x to the 6th goes in the bottom. And finally, number 21. 3 logs, you condense, of course. I see a plus, I see a plus. Those guys go in the numerator. I see a minus. That guy goes in the denominator. Power, power. Oh my God, a power of 1/2? Nah, that's not going to scare me because I know that anytime there's a fraction, it's power over the root, which means that this is a square root. So, in one shot, there's the answer. Log base a, because they all have a base a, of the square root of x, power 1 root 2, there's your 1/2, y cubed, and those two are positive, so they go in the numerator, and then the last guy goes in the denominator because he is negative. Okay, that takes care of these examples. So now your job is to complete letter A right before that. If you had already done B, I'm happy that you were able to see this video anyway. So now you get to correct your answers based upon what you had before. And so remember, you are supposed to finish B, go back and do letter A, and now you can also do questions 1 through 80 on the big log packet, okay? So the next lesson will be on the next assignments here, which will come next week. It is on exponential and logarithmic equations, and we'll take care of those in the next lesson. For those of you that this was too slow, I try to go a little bit faster by doing them ahead of time. Stick around and I will do it in 30 seconds. Why can I do that? Because I'm Mr. G and I'm Speedy G and I can do this, all 21 of them in 30 seconds if I go in fast motion. So stick around and you'll see the video as I will do all 21 of these in 30 seconds. Ready, set, go! See you real soon, and until the next time, this is Mr. G signing off saying if I can teach from anywhere, you can learn from anywhere. Hasta la vista, baby!